So in this video, we're going to continue our work in Introduction to Functions. This would be a great place to review everything that we talked about, and also maybe even to learn for the first time if you have been absent for a little bit, right? So you're in the right place, moving along. Hopefully you printed out the assignment. If you need a copy, let me know. So we want to determine the domain and range in this problem. We want to understand that the domain is the x values, the set of possible x values, and the range is the set of possible y values of our graph, of the points in our graph, right? So every point has some coordinates, right? We could take this point right here that we're looking at, okay? The x coordinate of this point, I follow up to this, and I find the x-axis, right? Go to the x-axis, and I find 6. That's the x coordinate of this blue point, all right? If I follow this at a right angle over to the y-axis, right? Again, that's the y-axis, this one. I see that this goes to -5, right? It's in between -4 and -6. So this is the point, -6, -5. I'm sorry, +6, -5. So when we write the domain and the range, we basically are making a list of all of the x values and a list of all the y values that our points can possibly have. So there's a couple ways to do this, right? One way would be just write them all down, and then afterward you can kind of organize them, because you might notice that the domains have been written in increasing order every time. All of these are written in increasing order. So if you write them in increasing order, it'll be a little easier to compare whether or not the lists are exactly the same. So let's do that, okay? We're going to take a look at all of them. So instead of doing this any other way, what we're going to do is we're going to label all of these points with some letters, and then we're going to write the coordinates of all of them. All right? Now, I highly recommend that everybody does this as a warm-up right now, because it's so fundamental that if you don't know how to do this, you're going to be going really slow later on, and you might even give up. So I don't want that to happen. So what we're going to do is write the coordinates of all these points. Okay, we got A, B, C, D, and E. I believe in all of these problems I gave there 5 points. So that's enough that you have to pay attention to one graph for a while, but it's not too complicated that each problem is going to take that long, okay? It's just long enough, I feel like. So we want to find the coordinates of A, all right? So don't forget that, that's, 7, 5 is in between 4 and 6, 3 is right here, right? 1 is in between 0 and 2, right? So we got to understand that in the middle, we have 0. So both A and B have an x coordinate of 0. Okay, so let's talk about this a little slower. One thing I want you guys to learn: every point on this line that I'm drawing in blue will have x equal to 8. Okay, that's the way this thing works. Every point on this vertical line will have all of its x values equal to 4, because that's the way this works, right? So what we're doing right now is to realize that this one in the middle, a lot of times people get confused because it's in the middle. So it's not positive or negative, it's 0. So we got to realize is that the y-axis, okay, the y-axis is the line x equals 0. That's kind of confusing because it says y right there, okay? And then we got to realize that the x-axis is the line y equals 0, okay? So every point on the x-axis has a y equal to 0, and every point on the y-axis has an x equal to 0. This can be confusing until it isn't. There's only really one way to mess this up, so it's natural that every now and then you will mess it up, but eventually you will no longer get confused about those. It just takes a lot of time, and we'll start that path right now. Okay, so like I said, to get B and A, they both go back down to 0, so that's the x coordinate there. So let's find the x coordinate of C. I'm going to follow C back down to the x-axis right here, and I see that is -1. So the x coordinate of C is -1. Again, these are in order, right? The first number has to be the x coordinate. So on D, I'm going to follow up to the x-axis, and I see that right there, that's -5. So the x coordinate of D is -5. Now for E, I'm going to follow this up to the x-axis, and as we saw earlier, that's at 6. So the x coordinate of E is 6, okay? Now that I got all the x coordinates, why don't you test yourself and try to get all the y coordinates? Let's see if you understand what those are. Okay, now the y coordinate, maybe I'll do those in a different color. The y coordinate of A is going to be 7, okay? So it's right there on the y-axis at 7. So this is the point 0, 7. B is right here at the point 4 on the y-axis. So B is the point 0, 4. C. Okay, we can see that if I follow C over to the y-axis, we get to this point 2, right? So the y-coordinate of point C is 2. Okay, what's the y-coordinate of D? Okay, we're going to follow this all the way over here to the y-axis, and we see a point that's negative 2. So the y-coordinate of D is negative 2. Now we get to this value, E. Okay, and we see 6 is right here. Now let's follow this over here to this thing, and we see negative 5. Okay, so negative 5 is the y-coordinate here. So now take a look. We're done. We have everything that we need to solve this problem. Now usually you won't have to do all this writing, but because this is the first time we're doing this, we have to go over all the details. All right, let's find the domain. Okay, the domain is a set. Okay, and a set is just like a list of numbers or a list of values, a list of things. So in this case, the domain is going to be, we're going to start with this object called a curly brace. Okay, so I'm going to try to do this a little slower so that it looks nice. There we go. This is called a curly brace, and these are these symbols that you see down here. Okay, we put our list inside of there. So the domain is going to be a list of all of the x values that we had in our points. Okay, if a value comes up more than once, then we won't write it twice. We just write it once. Okay, so we want to write these in increasing order. So what's the smallest number in this x column right here? Right, the smallest number from this phase right here is, what's the smallest number from this side? Right, the smallest number is not 0. It's actually negative 5. So I'm going to start with negative 5. Okay, the next number in the list would be negative 1. That's the next smallest number. And then we got 0. Okay, and then the biggest number in the list is 6. So we'll put 6 right there. Okay, now we'll close the set with another curly brace. And there we go. That's the domain. Now we'll do range. Okay. Again, just to make sure you guys got that, the domain is all the possible x values of our graph. Okay, in this case, our graph was just these 5 points. Okay, a graph is always going to be a collection of points, but sometimes they'll be connected with a smooth curve. Sometimes they won't be. For the range now, we're going to get the list of all of the y coordinates. So in this case, we can have them increase because it looks like they're doing that too in this value, right? So what's the smallest number from this side, right? What's the smallest number down here that we see? Well, the smallest is negative 5 and then negative 2. So we'll go write those into our list. Okay, so we're going to write negative 5, right? And then we got negative 2, and then we got positive 2, and then we have 4, and last we have 7. So this problem would be complete as long as you can read it and choose the correct answer, right? What is the answer for this problem, right? Which one would you choose, A, B, C, or D? You're going to have to persist and read the ones that you need to read, okay? So maybe I'd start looking for the domain of negative 5, negative 1, 0, 6, okay? And I see this one right here, C has that. Notice in A, it contains 2 in the domain, okay? But there is no point at x equals 2. You see that? This is x equals 2. There's no point there, okay? So this can't be. That's not true. Okay, it can't be A. But if we take a look at C, we see that we have negative 5, negative 1, 0, and 6, just like these values here. Okay, now just verify that the rest are the same. Negative 5, negative 5, negative 2, negative 2, positive 2, positive 2, positive 4, positive 4, positive 7, and positive 7. Okay, so our answer must be C. Okay, it's possible to do this without writing everything. Okay, but because this is me teaching this in this video, I went over every detail like I said I would. So if this is, going too slow, then feel free to move on a little faster. I'm not going to do this every time, but at least this time I'll let you guys see what you could do if you wanted to take your time with this problem. So now we'll move on to 24, and we'll have you guys think about what the answer is. Okay, so you might want to make your choice up here. We should understand that the domain, again, is the x values, right? So I can see that the leftmost point, right, if I start from left to right to get my domain, that would make sense if I write those numbers in that order. So let's do this a little faster now. I'll try not to lose you, but we want to go faster. So the domain. Okay, the domain is We're going to start at the left and we're going to work our way to the right because we're going to write these in increasing order. So I'm just going to write a curly brace and then we'll just start writing the coordinates of each point. What's the coordinates of this point? The x coordinate is -5. So I'll put -5 in there. Okay, let's go to the left and get the next point, this point. The x coordinate of this one is -4. So I'll put -4 in the list. Notice I avoided writing everything down because you don't have to always write everything down. Okay, 0 is right there. So the x coordinate of this point is 0. Right? The x coordinate of that blue point right there is 0. Okay, now what's the x coordinate of these 2 points? These 2 points have the same x coordinate. It's 2, right? So the last number in the domain is 2. So I hope you can see it doesn't have to take that long. Okay, now we'll get the range. I'll write that in red. Okay, so to get the range, we're going to start at the bottom. We'll find the minimum value, and then we'll work our way up, and we'll write those numbers down. Okay, we can see here that the lowest number is -7. So we'll move up to the next biggest number. We have this one right here. That's -5. So there's a -5 there too. Okay, we keep moving up and we get to this point. Okay, this point has a y coordinate of 1. So I'm going to write 1 right here. Okay, and then we see that these 2 points both share a y coordinate of 7. So we have +7 right there. Notice we don't have to write it twice because that's the possible values right here. So now that we take a look at them, can you find that answer anywhere? And I'm hoping you could see that this is option A. So as I said, writing them down can be one way to solve these problems quickly to make sure you know what we're talking about. But I mean, really here we're trying to master the concept of domain and range because we're going to be stuck with these ideas for a long time, like maybe more than 4 years. You guys will be using this in calculus still. So when we continue the next one, I'm hoping you guys can make a choice, okay? And I'll project the answer so we can talk about why it might not have been one of the other ones. Okay, so make your choice, and I'm hoping you see the answer is D. Okay, we can notice right here on this example that there's 3 ones that were not chosen, right? D is the only correct answer. So why are the other ones false? Let's take a look at that instead of anything else, okay? This one says that it has -5, 0, 3, and 6. All of those are points that I see here for x values. But what about -4 in the range? Yep, we got this one. What about 1 in the range? Okay, 1 is in the range. What about 2? Is 2 in the range? Yep, 2 is in the range. 6. Is there any value, is there any point with the y value of 6? Look, there's none of the blue points are there. So that's why it cannot be this one. You see what I mean? So you can always identify maybe a reason why it would not be the other ones, right? Notice here in the range, this one says 7 is in the range. There's no points up here at y equals 7. There's nothing there, okay? So it can't be this one either, you see? It can be kind of easy to see when it's not something, which is really what I'm trying to show you is how to read these graphs. Okay? So again, follow that step and you'll be able to understand what's happening and hopefully this all makes sense to you. Again, this last one, A, 6 is not in the range, right? There's nothing there. So we could eliminate A like that. So process of elimination is pretty useful. It's really helpful because you're going to use that in multiple types of tests. So practice it, all right? Critical thinking. All right, for this problem, we'll make a choice, I hope. Pause the video if you need to and make a choice. Write numbers down and see if you can learn. Okay, the answer for this one would be D, okay? If you can't figure out why you're wrong, this would be, something you want to write down. Make a note, put a post-it on that thing, highlight it, and come ask me about it if you can't figure out, okay? If you're confused about something that is really simple, I might be able to explain it to you in like 10, 15 seconds, honestly. So have the patience to ask a question. Okay, so now we're done with that set. Now we made it into this part that's talking about determining whether or not it's a relation based on just these numbers, okay? So, similar to what we said earlier, a function is a function if each input has only one output. So let's go take a look at what we want to focus on here, right? We know that an ordered pair works like this, right? The first one is x and the second one is y. We call that an input and we call the other one an output. Okay, so what we want to do is make sure that none of our inputs have more than one output. That's all we're checking. So we need to make sure that we check every input. So I'm going to highlight all the ones in left in blue. All right, you see those? Those are our inputs. Are any of those blue numbers, are they repeating, right? There's no other -7, right? Is there any other -6? Nope. Is there any other 0 in any of these places? No. Is there any other +2 in the x category, right? No. None of these x values are the same. 7. I look in the x spot to find 7. So I didn't see any of those repeat. Okay? So that means that this is a function. Okay? We can't say that it's not a function. To say it's not a function, we have to find one input that has more than one output. Okay? So this one, we can move on. Let's see if we get a good non-example in a second. And here we do. We got one. Okay? In this case, you should be able to see that this x value and this x value are the same. So that means that we have two inputs that are the same input, but it looks like they have different outputs, right? So again, the x is here. That's the x. And the x's are my inputs, right? The x is my input. So look, I have one input, right? -6. And it has two different outputs. One time it outputs 1, and another time it's outputting 2. So that means that this is not a function, okay? That x value came up twice, and it has two different outputs. So that's enough to say it's not a function. Another thing a student mentioned was like, well, hey, also look that there's -5 and -5. So those are another reason why this is not a function, okay? But all we need is one example. One example of an input that is repeated with a different output. That's all we need to see. So for 29, we should be able to see here, is this a function or not a function? Okay, make your mind up. Okay, this is not a function because we have +6 and +6 associated with two different outputs. Okay, that's confusing. If I plug in 6, I don't know whether to get back -5 or 3. Okay, so we don't want that. Okay, make your mind up for this one, for number 30. In this case, it's not a function because we have -6 and -6. So those inputs have two different outputs. Look, one time it's associated with the output of 5, and it's also associated with an output of 7. Okay, so that's confusing. -2 also comes up twice. That's another reason that we could say that this is not a function. Number 31 now. Okay, make your mind up. What do you think? Is this a function or not? This is not a function because, again, we have +2 and +2. And we have two different outputs. So that will not work. Okay, the next one is 32. Make your mind up. What do you think? Is this a function or not a function? This is a function. Okay, the only number that came close to repeating is -4 and +4. Okay, and +4 and -4 are not the same thing. So this is a function. So at this point, we're looking at something similar to what we did before, but finding the domain and range without an actual graph. Okay, now we're just looking at the ordered pairs, right? The little points, right? So 7, 7 is 1 point, -6, 7 is 1 point, so this is represented 5 points in this set, okay? So let's go take a look at what we should get. All right, here's the thing we want to know. Everything that I'm underlined in blue is the x coordinate, right? So those are our domain values. So all we got to do is make sure that those go into the domain. Okay, so which one has -7, -6, 0, 2, and 4 for our domain, all right? That would appear that only B has that possibility, right? So we already know that we found our answer, but we still will check the other ones, right? So there's Y, there's Y, there's Y, there's Y, there's Y, right? All of these ones I'm underlining in red, those belong to the range. Okay, so the ones on the left are the domain, and the ones on the right are the range. And so if we look at what the range was, I mean, we can see the domain, these points were written in order, right? The x values increase. But the y values are not totally increasing, right? This is 7, then it's -2, and then it's -6, so it's all over the place, right? So we got to think about that. We're going to have to be patient when we write the range. So I'm going to show you guys how that might look if I was going to write the range and I'm looking at everything here. All right, what you got to do is understand that we want to start with the smallest number, so that's -6. So look through the whole list and see what's the smallest. The next smallest is -2, so we'll put -2 right there. What's the next biggest number? The next one is 0. And then after that, we have 7 comes up twice, but we're not going to write it twice. We only have to write it once inside of our range. And so now we can see that B, we've expressed everything that's contained inside of B. Okay, so just think about it. All right, I'm showing you like 5 different ways to think about the domain and range, and we want them to be really quick, right? So again, the domain is just a list of all of the possible x values from our graph or from our function, from our set of points we're looking at, okay? And the range is the set of all the y values of our points. So now we can continue doing some of those. All right, so make your mind up on 34 and see what you think has to happen. The answer that you got should be B. So again, just double check, right? The ones on the left are negative 6, negative 4, 0, and 2. And notice that those are right here, okay? None of these other options even had negative 6, 4, and 0, and 2. So 35, try this one on your own. See if you can make sense of what we've been doing. Okay? Just walking up to this problem, I can see that negative 6 is the smallest value, so I could go look at all the domains and see, does any of them even have negative 6? Hey look, this one has it. This one does not have it. I mean, it has negative 6, but it starts with negative 7, and there is no negative 7, right? So I know I'm not going to pick D. So the answer here would be B. Okay, so if you can even read a little bit of these things, you'll be able to solve the problem without doing much thinking. You just have to be able to identify, oh, negative 6 is in the domain, and these other ones do not have that number. So now 36, make a choice. See what you think. Pause it if you need to think for a second. If you need to take a break or something, take a break. Pause it and come back later. All right, here we go. The answer we should have got is C. Okay, so again, you can double check that we have negative 6 as our first one. And look, this time we had 3 different possibilities that have domains of negative 6. So you just have to keep looking, right? This says negative 1, and we can see, hey, none of these other points have a negative 1 in their x value, so it can't be A. So you keep eliminating them. All right? We can find a reason why it's not B, right? This one also has a negative 1, and that's not there. So I'd be able to cross that out. So we're stuck with C as the only answer that makes sense. Now, for 37, make a choice, and I hope you're finally starting to choose right and it doesn't feel like you're doing too much confusion. All right, for 37, we got A. 38, make a choice. You should have chosen C. Okay, so again, just double check. Notice the smallest number for the y values is negative 7. And I see 3 of those have them, right? The smallest number here is negative 3, so I know I could cross out A. It starts with negative 5. I could cross out B because that is negative 4. So, you know, eliminate things and work your way to the answer. Great. So here at this point, it seems like we might be ready to continue moving on to graphs. So we'll do the vertical line test right here. Okay. So at this point, we're ready to understand this concept called the vertical line test. So I'll have you guys write this down. The vertical line test. So to do the vertical line test, we're going to need a vertical line. So what I'm going to do is put a line right on top of one of these grid lines so that I can make sure that it's pretty straight. There we go. So we have this vertical line. Okay, the way this works is that we want to understand what we're even doing. Okay, determine if the relation is a function of x. Okay, it's kind of important. Usually if somebody doesn't mention what they're talking about, a function being of what input, okay, then they probably mean a function of x, but it's not always clear. Okay, sometimes the context might be a little different. But just understand, we should probably be specific that we mean it's a function of x. Okay, so since it's a function of x, we want to see if the input, which is our x, has 2 inputs, right? That's what we're checking. So what we're going to do is we're going to use this vertical line and we're going to scan our graph. Okay, so in this case, our graph is the circle, or this oval, I mean. Okay, and this oval is in blue, and that's the graph that we're talking about. Okay, so what I'm going to do is start on all the way on the leftmost side of this graph, and I'm going to pass a vertical line over the graph. And what we're going to do is try to check to see if there's ever a place where the line crosses the graph in more than one place. Okay, does this vertical line cross the blue oval in more than one place? It does, right? Right here, I think you guys can see that this line, this vertical line, is crossing the oval in these 2 places. Okay, and because of that, I can say it's not a function. Okay, and let's talk about why. After everything that we've done lately, we know that this is the point 2, negative 1, and that this up here is the point 2, right? 5, because that's in between 4 and 6. So notice the 2 is the input, right? That's the input. And look, it has an output of 5, but this one has an output of 1, -1. And these are two different outputs with the same input. So that means this cannot be a function, okay? Because that one input has two outputs. So the only way a thing passes the vertical line test is if we find a place where it never crosses into places, okay? So we want to test, okay? So the vertical line test means check if the graph crosses a vertical line more than once. All right, so that's the idea. That's the vertical line test. So we'll go use this on these problems. It's the only way to do it. It's really kind of a simplification of what's happening here, but it's very simple to understand graphically, and this is something you should be able to do by looking at it. So most of the time, the vertical line that you'll use will be your pencil. So let's go try it. All right, number 40. So again, make your choice right now. What do you think this is, okay? We're going to drop a vertical line, and we'll go test to see what's happening. So I'm going to put a vertical line right here. All right, and then we're going to scan our graph. I could go from left to right or right to left. So let's start on the left side like I told you last time. All right? Right now, is it crossing in more than one place? No, it's only crossing right there at that place, right? So if I go again and move it over a little bit, what's happening? Right? It crosses in one, still crossing only in one. Okay, but we can see, wait a minute, this curve is starting to turn back around, and finally, right here, it crossed in two places, right? It crosses here, and it crosses here. So this is not a function. That's all we need to do is find out if a vertical line will cross it more than once, because that means our x value got two different y values, and that means it's not a function of x, okay? Can't be a function of x then. All right, this would be a function of y, all right, but that might be going over your heads for now. So anyway, we'll take a look at 41, okay? Is this a function or not? What do you think? Make your mind up. Make a choice. Okay, and maybe even do the vertical line test like I've been showing you. That's what you should do. Okay, and what do you think? Did it pass the test or not? So you go find out. So we're going to scan it. Okay, I can go from this side, and I see right here at -1, it crosses in those 2 points. Those are solid points too, by the way, right? Okay, but what about right here? This place crosses the blue graph in that place and that place. That's 2 points. So this is not a function. All right, it's that easy. We can move on. All right. So it's not a function of x because a vertical line crossed in two places, okay? So now we'll take a look at the next thing. Let's see what happens with 42. Okay, can we get a vertical line that crosses this in more than one place, I wonder, right? Well, that's what we're going to do. So we'll put our vertical line right here. Then we'll scan it. Okay, so we could start on either side. Like I said, let's start on the left this time. All right. So I'm going to scan this one. We see it's only crossing in one, only in one, only in one, only one, only in one. It's all in one, except until right when we get right here. I hope you guys can notice that I'm about to put 2 red points where they're going to cross. I hope you guys can see that these 2 points lie on the same vertical line. So not only does it cross in those 2 points, but it crosses in all of those, right? So now when I go put this this line and move it over, look what's going to happen. Where does it cross? It crosses right here, right? It crosses the blue line in all of those points. It's like an infinite amount of points in that little section, right? So this is not a function. Again, it can't cross in more than one, and that's definitely more than one. So we're moving along. We're almost done with this video. There's a lot of details that I told you guys would come with this one, so we're doing the details. Okay, again, on this one, you guys should be able to see that this is not a function. Okay, why? What was it? It looks like it almost was. It was pretty close. But you guys need to see that this point right here, right, and that point right here are on the same vertical line. So those 2 points are going to be not passing the vertical line test, right? That's 2 points. This is not a function. Right? That's the one we got to pick right here for that. Okay, so now we're going to get to number 44. Okay, see what you do. Make your mind up. What do you do in this problem? What do you think? What does this mean, that it is a function? Okay, if it's a function, it means that there's only one output for each input. It means any vertical line will never cross it more than once. So let's do the vertical line test. All right, this time we can go from right to left. Okay, so I'm going to start here. It's only crossing one place, one place, one place, one place, one place. Only crosses in one place in all of these. It's still crossing only in one, only in one, only in one, only in one, only in one. Okay, so this is a function. Finally, we got an example that passed the vertical line test. Okay, if there's a couple examples left for you to do, you should try them on your own before I do. Okay, you want to make sure that you kind of have the idea on your own. All right, so it looks like that part's finished. So now I think we can get through this part, and let me just double check where we're going to stop in the video. So yeah, interval notation is going to be a half hour long, so that'd be too much for one video. So I'm going to break the video up right now. So this got you up to, where we got up to, and now we'll start talking about these other ones in the next video about the domain and range, interval notation, the inequalities that show up on numbers 53, 54, 55, 56, all of those. Okay, we'll work on that stuff. So good luck studying. Watch part 3 of Introduction to Functions.